Okay, let's do a little bit of fiddling here with this leetcode problem. I doubt this is going to work, but you know what? Let's find out. Fold out list cycle 0 function. Okay. Oops, hold on. Lambda x result plus 2 result. No static. Interesting. Okay. Mm-hmm.
Yeah, though this solution is pretty clever, I think. Which is why I'm motivated to complete it. Hmm. And I have immediately to take a break. Well, that happens. Alright, I'll be back. Okay, if I remove duplicates on nums, what do we get? 8, which is still 2 times as many as we want. Let's do the other example and see if we also get 2 times as many. Well, the other example, piece of shit. Okay. 12, no. Mm-hmm. Alright, is this a lesson in perseverance or is this a lesson in is this a lesson in not forcing myself to spend time doing something I'm having a bad day doing? Yeah, I like how clever this solution is, though. And I want it to work, but... Mm-hmm. Yeah, well. Alright, so let's go move on to beautiful Racket. I mean, maybe we should have a preference for going to Emacs. It's like we can muddle through Emacs for educational purposes up until. But then we have to recomplete setup because. Yeah. Um. Hmm. Yeah. Okay. Um. Mm. Hmm. Hmm. Yeah, we probably want to. I need to look into this at some point, but we can go ahead and read this. Hmm. Okay, let's go back. It's not what we're doing. We are doing make a language in 1 hour. Hour 6, hour 7 of make a language in 1 hour. Why does that always happen? Uh. So we would typically do this with a let definition. So I will do this with a let definition. Let arg car stack and then return arg. Okay. Right. Okay. Mm-hmm. Afraid we spread this out over too many sessions. So let's see. Whoop. Hello. Maybe I need to do something more exciting than what I'm currently doing. Hello. I'm trying to learn about macros, but that's probably not exciting to watch, and I rarely have an audience. I guess we could do a leetcode problem. Who wants to do a leetcode problem? Hello, everyone. I failed at doing a leetcode problem earlier. We could try to fix that one. Sounds exciting. Let's do that. Okay, sure. Or since I'm already failing at this, we could try a different one. Alright, let's do an off the top of my head leetcode problem here in Racket. Let's see. I have everybody's names hidden because my chat is permanently broken. Brent Arata. Hello, Arata. Check if in and its double exist. Well, let's do this increasing decreasing string. Alright, let's do a leetcode problem. How exciting. You are given a string S. Reorder the string using the following algorithm. So we're going to have to return a string, notably. Remove the smallest character from S and append it to the result. Remove the smallest character from S that is greater than the last appended character and append it to the result. This is like a sort greatest to least with chars. And no, that's not what it is. Okay. Remove the smallest char from S and append it to the result. Okay. Huh. So we could do string to list and perform various list operations. Try to complete this entirely with folding. Remove the smallest character from S that is greater than the last appended character and append it to the result. This rule set is horrible. So what is this saying? Remove the smallest character, so lexicographical ordering. Append it to the result. Okay, but append it to the result, so that would seemingly mean place it last. So we would start with an empty string. I mean, we're not going to run string append because that's inefficient. We're going to create a list probably. And then run list string. Remove the smallest character S that is greater than the last appended character. So seemingly so we'd have to increase lexicographically every step, because this is saying remove the smallest character and append it to the result, then remove the smallest character that is greater than the last appended character. Okay. So we could run a hash table that tells us the, let's see. No, because the hash table isn't going to be useful for lexicographical ordering. We could have a heap where we sort based on lexicographical ordering. But the problem with that is that we would need to have const pairs where the char is in front and then we have a position value. Because we need to be able to find the value again in the string. Well, actually, why do we need to find the value again in the string? Yeah, fair point. We don't actually care about the string after the initial engagement. So if we cycle through the string and update a hash, then we don't need to know the positions. We only need to know the number of each char, how many of each char we have. Okay. Then, okay, but we still have the problem. We still might need a heap. Because we still need our lexicographical sorting of yeah. So, yeah. So we could create a hash table and 2 heaps, but that already sounds like we're doing a lot more than we should be doing. What's the idea here? So we create a hash table that tells us char to count, and then we have 2 heaps, one that is ordered by less than lexicographical ordering and one that's ordered by greater than lexicographical ordering. No, I can think of a way to do this with 1 heap and 1 list instead. Or actually it would be a heap, then a list, and then only a list. Okay, let's begin by making a string hasher. Alright. Oh, chat, extra talkative today. Hello, chat. Let's see, so what is the definition here? Source string S. Okay. Now what? So, string cycle. Alright, so we're probably going to have a string dope. Okay, how do we dope this string? And this is asking what do we place in the zeroth position so that as we decrement the counter, or as we decrement position down to 0, we hit a pre-placed element that triggers a guarded termination condition. So we're cycling backward through a string, we hit position 0, we've loaded up an element into the string. What do we need it to do? We're not performing any checks. Yeah, that's a problem. So we're not performing any checks on these elements that could replace a 0 check. What do I mean? So we're going to have an S string, S position, and now cond negative S position, then, and we also need a hash table of chat. It's a lot of parents. Oh, it's gonna be a lot more. That's just, I do this to get rid of some text that shows up over here. That annoys me. Which language is this? This is Racket, which is a Lisp dialect. Okay, and then we're gonna have a hash char dot count. Okay. Okay, so negative S position, we don't know yet. We could handle the last case. We could use 0 instead of negative, and then that would let us put our let up here. Okay, so active char string ref s string s position, and now not negative because that will error out, but rather 0 s position. I'm suspicious of this. I'm suspicious of 0 because it's probably, I think it's cheaper to, okay. I think it's cheaper to ask if a number is negative than if it's 0. So the question is, do we want to keep our pristine let definition placement, or do we want to keep our negative check? I think I'm going to keep negative. Okay, but then that means that we have to run if. Actually, we can copy that. We need to run if. Okay. Now else let active char. Actually, we could do for each. Let me think here. For each with range. I don't know that that would be faster. Well, we don't get the benefit of a string dope, so we can't guard our termination check, which would be our advantage over. I don't want to learn about the language that's based on Arnold Schwarzenegger. Let's see if. Let's see. Right, so we could use range and run for each, and then we would not have to define a function. I mean, yeah, again, our advantage in defining a function would have been dope, which would let us avoid termination condition checks. But if we don't have that, well, let's just code this up and then. Alright, so negative s position something, otherwise let active char string ref s string s position. Now, well, I mean, the whole thing is why I'm wanting to convert this into a for each expression is that the whole thing is s string sub1 s position and hash set hash char dot count active char. Actually, we don't really need this let definition either. Yeah, okay. Alright, let's see. If you insist. And actually we'd have to run string ref twice because we have to do add one hash ref hash char dot count string ref s string s position. This would be another question I would ask if I knew assembly. We could form a let definition on this string ref, which means that we don't have to perform the string ref twice. But then we already have the value stored in the string, so is it better to store a copy of that value in a let definition, or is it better just to keep the value stored in the string effectively? Anyway, so let's see. String cycle, fine. There's your parents. It's not an error either. Alright, so what do we do with the output of this? So we have our hash char.count. Alright, now this is a process of, oh, so do we also need a heap? Yes, okay. Heap char. So we could type heaps on the basis of their ordering. Actually, can heaps do lexicographical ordering? Let me see. Yeah, I think so. Make heap. Yeah, looks like it. Alright, so what is the Racket's char? Let's see, char less than. Do we have whether these are distinct characters? No, they're not. Okay. Well, why would I care? Probably wouldn't. Alright, just char less than. Alright, so there is an exclaim in some of the method names. Does that mean the method mutates object? Yes. Though that is discouraged because this is a functional programming language. Okay, so now we're going to have a heap. Oh, well, we need to heap add then. Yeah. And actually, yeah, we're going to have to use. I don't think we can have immutable heaps, unfortunately. Let's see. So this will be begin heap add. So the heap should retain its lexicographical ordering, like it brings it into the function. So heap add, which should have, yeah, exclam, heap char. Am I job searching? No, I don't think I'm ready for a job. I don't think I'm good enough at coding yet. Am I in need of one? Yes. Let's see, heap char. What are we adding? Right. Which experience do I have? Not enough. I've been coding for about a year. Heap add, heap char, stringer of S string S position. Damn, yeah. And in this unemployable language, self-taught, yeah. Heap add. So at the end of this, we're going to have a heap. Okay, and we're going to have a hash table. Okay, and now what we want to do is heap cycle. Find heap cycle function, heap char, along with hash char.count. Sick of selling coffee and getting yelled at by customers at Starbucks. I see. Yeah, I could see not enjoying that. Let's see. So we're gonna cycle through the heap elements. But we're gonna have a list. So this is gonna be heap cycle, and then let's see. Sorted list char. Okay. Just vibe code it. I don't have a subscription. Also, that would be beside the point, I think. I'm learning how to use syntax, so I don't think we should just vibe code it. Let's see. So we're gonna cycle through our heap. All right, so why this language if I want to get a job in tech? I learned this language so that I could study structure and interpretation of computer programs, which is taught in Scheme. That's a book from MIT. it's taught in Scheme, but Racket works almost perfectly with Scheme. Taking it the slow way. I'm also studying math. What do I want to do as a job? I don't know. I mean, the reason I'd be willing to become a coder as a job is because it gives me practice at a mathematical activity. I'm studying math and computer science, so I mean, math and programming. So if I get a job as a mathematician, I'll code on the side. If I get a job as a coder, I'll do math on the side. I just want to be thinking all day. Alright, so heap cycle. I'm trying to think if we can have doped the heap. A path for machine learning already. Yeah. Could get into that. That would be preferable to, I don't know, running a back end on a website or something, I don't know. So can we dope the heap in such a way? Well, no, because we're not performing... let me think here. Yes, we can dope the heap. Have fun? Alright. Will do. Thanks for stopping by. So we can dope the heap here. And the way we dope our heap is... Well, so these are going to be letter chars. They might... Yeah, they're lowercase as well. If I look at ASCII table, we have... All capitals are less than... I guess it wouldn't be capital. We could dope the heap with curly bracket. And then we pre-dope the hash with... let me think here. We pre-dope our hash table with curly brace to... curly brace to 0. That's obscure, but yeah, okay. So what is the idea? So the heap is going to have curly brace in it, which is going to be at the max position. Okay. Because the heap is going to be sorted by lexicographical less than. Okay. And then our hash table is going to have -1. Okay, so actually this will make more sense after I code the... So let min char heap min heap char. Okay. And then let star ref count hash ref hash char dot count min char. So we don't have to have a fallback condition because we've pre-doped the hash table. Okay. Now when we cycle through to the end of the heap and we run hash ref on that char, we're going to get 0. Yeah, that's interesting. So we're indexing to -1. Yeah, so I can ask negative instead of 0, which is a horrible habit, but whatever. So what is the idea? Let's see. Right, so we're going to hash the curly brace to -1, so I ask... let me see... No, not quite sure. Let me see here. Heap min, heap char. Just the least lexicographical. What question am I asking about the ref count? Okay, yeah, let's see. Yeah, we could do that. I'm not sure that... hold on. No, actually, I think the cond is... I think we're supposed to ask greater than ref count 1. Though if we did index to -1, we could ask positive ref count instead, which is probably cheaper than asking greater than status. Let me think here. Yeah, so 0 would count as 1. Okay, positive ref count indexing dot count to 0. All right, positive ref count. Then we're going to say okay, so here we have to perform hash set. So this is begin hash set. Well, actually, we can use an immutable hash table. We just can't use an immutable heap. So this is going to be heap remove min. Does that need an exclam? Probably. Heap remove min. Yeah. Okay. Heap remove min. Heap char. Min char. Okay. And then call. So we know we're not at the end of the list because, rather, we know that we're not at the end of the heap because we're going to index our count to 0. Rather, we're going to, what a complicated process and how difficult to explain. Yeah. Function heap char hash set hash char dot count min char sub 1 ref count. So that's decrementing our count. Okay, so we actually need 2 lists. We need output list char. Okay. And now the idea is that we const min char into sorted list char. Okay, and then we const min char into output list char. Okay. Now, so otherwise we don't have a positive ref count. We're indexed to 0. Now we ask char equals min char curly, was it open curly brace or close? Open. Yeah, that makes sense, doesn't it? Yeah. Let's see. Char equals min char open curly brace. Then we're at the end of the heap. Alright, so now we go to list cycle 1. Yeah, list cycle 0. List cycle greater than. Okay, function. Because our sorted list is now sorted lexicographical greater to lesser. Okay, so we're going to cycle through with, we still need the hash char.count. That would not be in front though, that would be, let's see. We want sorted list char, because that's what we're cycling through. And then we would have the hash char.count, and then I'll put list char. Okay, else heap cycle. Okay, with begin heap remove min. Did I say active? No, min char. Rather, heap char min heap. Yeah, that's confusing. I guess we should be doing heap with colon heap. Yeah, we could do that with a hash as well. That makes sense. Let's see. Okay, and then hash will get replaced with hash. It's kind of an update to our typing system, but we haven't encountered this strange conflict in our naming scheme before. Alright, so now heap remove min. Oh, yeah, we gotta delete that. Also don't like having that there. Oops. Just renaming in the way we did was a little bit careless, because a lot of needless renaming. Yeah, I should have been more careful. I didn't. Yeah. Oh well. Let's see. Okay. Alright, so begin heap remove min. Now we could also remove the element from the hash table. So what is this case that we're working with here? So positive ref count tells me that I have more than one copy of our min char that we just pulled out of the heap. Okay, so we pull that out of the heap. Well, yeah, because we have to cycle through the heap. Actually, no, that raises the question, why am I oh, well, because we would have to put these, yeah, we could put these chars into a list, and we could put these chars into a list and sort them at the end, would be an alternative to placing them into a heap. Might be preferable to do that, because there are a lot of the facilities of the heap that we don't need. We don't need to keep track of, like, we're not adding and taking away from the heap. So there's a lot of machinery in place that's there for sorting elements that get added that we don't take advantage of. We're just cycling through once. And then actually, for that matter, we could avoid this operation, which is a bit unwieldy. And we can still take advantage of the doping, because we can pre-dope the list that we fill from string cycle. Okay, I will copy heap cycle to a different tab, and we'll try to do this a better way. Alright, so we're not going to use heaps. still have to run the hash setting. Okay, and instead we're gonna have list char. Let's see, const string ref has string s position. Okay, this will be list char. So this naming scheme is a bit odd, but it's effectively saying that the typing, in this context, the typing is enough to know what it is that we're talking about. I don't really need to know a name for these. There's nothing to be explained about what these primitive data objects are doing, so I could be asserting anyway. There's nothing to be explained about what these primitive data objects are doing beyond what types they have. This is a hash that is storing char.count. I don't need a name, but okay, if I wanted a name, we could place it before the colon. So define string cycle, fine. Now at the end of this we have list char, and now the idea is that we only have to perform list cycle. And how does list cycle work? So lists, we'll do list cycle less than on let's see, sort list char by char less than. Okay, and now define list cycle less than with list char hash char dot count, and we needed null greater than list char. Yep, we can do that. Less than list char, greater than list char. Okay. And then null. Alright, so now, oh, and then null again. This will be output, or we could call it pre-string list char. Alright. Makes sense to me. Now let active char string ref, nope, car, yeah, okay, actually, let's do it like that. Car of less than list char be car of less than list char. Okay, now let's see. We could do ref as well. Ref, which is count hash ref hash char.count car less than list char with no fallback. Cond positive ref count. Then we have more than one copy. So we call list cycle less than list CDR less than list char hash set hash char.count. Alright, so this is where we decrement the counter associated with okay. Oops. Now const car less than list char 1, 2 greater than list char. So at the end we're going to pass this through to so this wouldn't be null, this would be list No, that would be null. This would be list curly brace. Open curly brace, right? Makes more sense. So what time is it? Yeah. Okay, so list cycle less than, CDR less than list char, hash set, and then const car less than list char onto pre-string list char. Alright, now we can, with the guarded case, we can ask char equals car less than list char curly brace open, then string to list a string, pre-string list char, else so we can, I still don't know whether it's better to remove elements from hash tables or not. Might have something to do with the count. We have 500 chars. Yeah, but there's a maximum of 26 because each char is only going to be lowercase. Interesting. Let me see here. So we have a maximum of 26 distinct chars that are going into the hash. Okay, and the idea is that 26 distinct chars are not so many to track. Okay. So we would be running list cycle less than CDR less than list char hash set hash char.count. Right, we're not, yeah, we would just pass forward the hash. Okay. Now const car less than list char. So you might, the counter argument to this naming scheme is to say that this doesn't allow me to speak a story that explains my operations that I'm choosing. I have to bear in mind what the relationship is between these. Whereas if I had names, I could tell a story behind that weaves the names together, and looking at the names would be enough to suggest a particular routing. Okay, now... Oh, so actually, yes, we would const this, but the point is that... No, we don't const here. So the reason we're not consting here is difficult to explain because these lists don't have names. Yes, I'm getting that criticism quite strongly, but... So we're consting these chars back into the next list. So this list is going to go to list cycle greater than, and we're going to perform the same operation except in the other direction with regards to this list. Okay. Now, I don't const on an element onto this list to perform the same operation if I have run out of instances of a char. So we have char.count. I decrement the count every time we encounter a char. I encounter those chars in these lists. If I run out of count, I don't need any more copies of them. So I don't const that element onto this list, but I do const it onto pre-string because we're putting the last copy of that char into this list that we're going to turn into a string. Okay, so onto pre-strings char. All right. Is there a way to know? Ah, that would be a trick. Is there a way we could force the termination condition to happen on one of these two functions? I'm gonna let that sit in the back of my head while we might be able to dope the primitive data objects. I'm not sure what we would end up doping to accomplish this, but we might be able to dope in such a way that our primitive data objects in such a way that we know which of these two functions is going to have the termination condition in it. Alright, so now we just have to replace a bunch of these. I think this one-to-one replacement is correct. Okay. So this actually isn't termination. We have to put an if. Okay, if we have to put in an if, we can do, right, we can do less than, okay, and now, this will be the else, well, the continuation, okay. So now we know char equals curly brace, list, null, what would it be? Null greater than list. Well, it couldn't be null. It would be, this is kind of, well, whatever, it's once per cycle. So char equals car greater than list char curly brace. Then we go to list cycle greater than with greater than list char hash char.count plus list open curly brace and pre-string list char. And then else list a string pre-string list char. Okay. Now what is the idea? This got a little bit more horrible than I wanted it to get, but it's a nice touch here that we can copy and paste, flip our signs, and be done. There's a rule we can follow here in using find and replace that works, but what is it? Let me see. So we have less than symbol that we want to replace with greater than symbol, but we also want the reverse. Okay, so barring syntax that we could put into the find and replace, we can do less than to at, e.g. Okay. Alright, and now we do greater than to less than. Okay, and now we do less than, greater than. Whoops, no, that's not it. At, rather. Do at to greater than. Okay. Alright, and we have accomplished the replacement. Now what? Okay, so that is done, probably. We should test whether this works or not. And then we can get into the horrible labor of string doping, of doping up this whole thing. String sort S. Okay. Well, so we need to call string cycle function. So that'll be S sub 1 string length S hash. This will be an empty hash, and this will be list open curly brace. Okay, and now string cycle sort string S. Oh, zero static checking, that's exciting. Okay. Char less than question mark. Oops. What is that one? Let's see. No value found for key. Oh, yeah, we need fallback of 0. Oh, and we need to pre-dope, so this is going to be hash to 0. Alright, is that the correct answer? No, but it looks like a reasonable... Wait a minute. Well, okay, yes, that did reverse the string. However, reversing the string is curiously not what we were trying to do. Wait, why doesn't that work? Oh, we have to ask a question about... Let me see here. So we're constting each string ref onto list char. But we're only supposed to... Yeah, okay, we're only supposed to const one on one copy of each char in the given order. Okay. So, we'll make a let definition here, let ref count hash ref hash char.count string ref s string s position. So, I mean, these string refs are, we need a fallback condition of 0. These string refs are stacking up, which is why I'm concerned about whether it's more efficient to have a let definition for this, or if it's more efficient repeatedly to string ref. The knowledge that string refing is a constant time operation doesn't answer this question, notably. Alright, so ref count hash ref, and now the point is we need to ask a further if question. If actually, we could do this with a Boolean instead. Interesting. If ref count slash Boolean. If ref count slash Boolean, then that tells me we have a count. Okay, and in that case I don't want to const. Okay, hold on. Yeah, we don't want to const in that case because we already have a copy of that char in our list char. We do need to add 1. We do not need a fallback condition. Okay. Actually, no, we've already performed this, so we can just do add 1 ref count, right? Okay. Now, if this is false, that means we've not yet encountered any instances of a char. So it's the same, except this will not be add 1 ref count, but rather it will be 0, because we're indexing to 0 for some horrible reason. Yeah. Indexing to 0 for some horrible reason, so we set the initial value to 0. And then incidentally we have a Boolean instead of 0, because then we would get caught in a loop where this returns 0 and we ask if 0. Alright, now sub1 s position s string. Sure, alright, now how does that work? Ref count slash Boolean. I went infinite, okay. Why did it go infinite? show me. Okay, so what are we seeing here? I'll let that run too long. Yeah. Okay, so that ideally is what my termination condition would catch. What do I mean? So char equals car greater than list. Oh, that's supposed to be our termination condition, right? Right, yes, okay. These need to be reversed. Okay, that's not right. Let's see. Am I passing pre-string list correctly? Pre-string. Okay, let's copy these over. Uh-huh. So we're never making it to... We're not filling in our list, evidently. Ah, yes, look at these. 0 additions to list char. Alright, so... let's see. If not count slash boolean, then const string ref s string s position onto list char. Okay, interesting. However, incorrect. Alright, this is a bit of a display here, but show me display hash char.count. So this says we have 3 copies of A. Well, it's indexed to 0. Curiously, for counting, it's indexed to 0. Okay. So ABCCBA is what we got, but we didn't continue with the process. So let me see here. Why did the process not continue? Show me. Okay, but yeah, so we do have that list. Display ref count. Display car. Display car. List char. Display ref. Display ref count. Line. Line. Alright, so now what is the idea? Well, actually, conveniently, we get the hash table each time. Let me show you that down here. Uh-huh. Oh. Well, that is a good change to make, but... Let's see... So wait, what is... That's a tricky one. Why is this turning out this way? Well, I rushed through the solution because you only have about 30 seconds to get people to stick around. So I had to do something in roughly 30 seconds that would get people to stick around. And now, well, the point was to stick the landing, which we did not do. Let's see. So we're supposed to take another cycle through. Actually, we're supposed to take 2 more cycles through, right? A, B, C, C, B, A, B, C, C, B, A. No, so 1 more. Mm-hmm. Hello. How's it going? Nameless chatter. Oh, Austin 03. How's it going? Let me see here. Yeah, we rushed through this though. I don't know. This is a strange one because I'm. Let me think through my logic here. So we have our less than list cycle. So we have the less than list. We have less than lexicographical sorting. And now we have car of the list. Okay, we run hash ref on element. If that's positive, so in this last case we're going to have positive, and we're in list cycle greater than, but it's a copy of list cycle less than. But okay, so if we have positive ref count, okay, but we don't have positive ref count, and that's because right, a critical display we've skipped is the car value. What is the car value here? Okay, so we have arrived at the curly brace. Fine. So we've reached our doped element, and what happens? So not positive because it's at 0. Char equals... Oh, we were supposed to... No. We arrive here. There we go. Char less than car of greater than list char. Okay, and that's the current element. Okay, and is that less than the curly brace? Not in this case. We're at the curly brace. Okay, so we move on. Char equals car less than list char. Curly brace. Okay, and the reason here is that this is a way of checking whether we've const any elements on the passback list. Which would be the less than list, right? Because we're passing back and forth between the less than cycle and the greater than cycle for the purpose of maintaining the ordering that we obtained in the initial function. Okay. And now... Take a break from your machine learning project you have for college and decided to watch someone program. What about me? All good? Yeah, I'm doing okay at the moment, though coding is about to stop. We have about 22 more minutes of coding before I exercise. So you'll have to find someone else. Actually, I'm also failing at this program at the moment, but we'll see. Let's see, so char equals car less than list. So the idea here is that we're removing elements from greater than list char and we're consting them onto the less than list. Okay, if I have const nothing onto the less than list, then the less than list will contain let's see, the less than list will contain just this symbol. So we've passed here to list cycle greater than. We have a list that contains open curly brace. That is our less than list. So when I down here ask if car of less than list char is open curly brace, that would trigger calling back to less than with this as the input list. And then this instead of null, instead of the null list. Okay, now the question is, well, okay, let's find out what this is. Alright, we'll go up here. So we'll do here car greater, and here display car less than, display here line, okay. So car less than is A. Now what is the idea? Well, char equals car of this list, open curly brace is false. We did not reverse this. Did we reverse that up here? Yes, I see. We should have copied this over. Okay. And now we have... did it. ABC, CBA, ABC, CBA. All right, now, let me see. I'm gonna copy this over without the displays. Alright, we could do this as a series of fold operations. I want to see the feasibility. The doping operation maybe makes that a little bit more difficult. Oh, you know, instead of asking char less than, we could do char alphabetic. I'm not sure if that would be any faster. Maybe not. Oh, and the last check here, could we force the termination to happen in one of these two cycles through even cleverer list doping? Maybe. How would we accomplish that? We would need to place, well, we have to place probably some concert between the hash table and our list. Oh, yeah, okay. Well, we could just put a different char at the beginning and at the end. Let me see here. And then we just don't place a termination condition in one of these. So we would erroneously pass back to the other function, but it would be one pass back to avoid having termination checks at all in one of the procedures. Okay, that also means though that we need a char that's less than, well, that's easy because the ASCII table, as the ASCII table will tell you. Yeah, well, actually, we could also rely on numbers, or we have a wide variety of chars that we can use that are less than the lowercase chars. Okay, so we have open curly brace after all of the lowercase chars, and then we have, again, take your pick of prior to curly brace, or prior to lowercase chars. Okay, what do I do with that? Let me see here. Well, and why do we want? Because, let me see. Wait, why would we need to place? Why couldn't we just? Yes, actually, that's actually the idea, isn't it? I mean that we only place a termination condition in one of these two procedures. And we have a bit of a hint as, well, no, I'm not sure if that's the best idea. So the point is that we'll send back a list that contains only the curly brace, and it's going to fall through until it hits the termination check. Which again is an erroneous call, but we were going to get that erroneous call one way or the other. All right. So, have I done real analysis? No, I have not. I know what I'm going to study. At least I know one of the analysis books that I'm going to study, but I don't think I'd recommend it. I don't have a good reason to recommend it to other people. I'm going to be studying Barrett, Bishop, Foundations of constructive analysis. But again, I'm not recommending this. I'm just observing that I'm going to be reading this. Because I want to investigate constructive mathematics specifically first, just to get an idea of what that's all about. All right, now, right, so we're going to eliminate the termination case. Never heard of that one. Yeah, it's specifically constructive methods only. I don't even really know what that means at the moment. I don't know if constructive only means like finite methods only, but that might be what it means. Foundation, so analysis only with finite numbers, or analysis by construction, but again, I don't know what that means. Dealing only with discrete. Yeah, that sounds reasonable based on what I've read. So analysis with only discrete operations then. Interesting. How could it be done? I don't know. Alright, hold on. How do we... Hope the study goes well, thank you kindly. Hope your project goes well as well. Hope this was a relaxing break. That is more realistic to what I encounter in real life. You mean the discrete math? I mean, you wouldn't... More people are going to study analysis with continuous methods. So if you want to follow along with the gist of analysis, you'd rather use continuous methods, I think. Let's see, does this still work without modification? Yes. Alright, that was a pretty good save. We just don't have a termination condition in this procedure at all, and then we have it over here instead. Okay, now, though, we might ruin all of that fun with the... Wanted to study topology. Some books use real analysis like a stepping stone. Yeah, that's also what I've heard, and that's also what I want to study at some upcoming point. And yes, that's why I'm passing through analysis as well. Then it might be bad for me to read the constructive only book. But yeah, I don't have a good recommendation. I don't know anything about... I haven't read any of them yet. Let's see. So one point is that we could probably wind up this procedure as a functional procedure. Let's see if this passes first. Wrong answer. For point set topology, you just need set theory and a good guide/author to guide you through it. The latter part might be the hardest part. Yeah, well, actually, that is the direction I was going to go. Hold on. Do I have to reverse? Why would I have to reverse? Yeah. But actually, thanks for the tip. I don't know if I've given you much of a tip. I don't know if I've given much good advice, but all right, good luck yourself. Let's see. So if we, I think the point here is that we need to sort based on char greater than and past a char greater than first. Why do I get null? Let's see. Oh, it's some curly brace. The curly brace is getting busted. Is that it? Why would that... Are we... Hold on. Right, I don't need to send in this curly brace. Do I? We pre-hash with the curly brace. So... No, yeah, but we do need that initial copy. Don't we? Hold on. Let's list char. Yeah, and then... Sort list char. Yeah, hold on. Let me see. Okay, but actually all that means is that we need to do... We need to replace the curly brace with... Yeah, we do need it in the list, and we need whatever we put in to be at the end, but that means that we can choose one of the ASCII options that's prior. So actually that's kind of a convenient mnemonic here. Curly brace for after and square bracket for before. Alright, so square bracket, and now we send in square bracket, okay, and now char greater than square bracket, and now char greater than square bracket, char equals car square bracket. We send back. Oh no, it started closing. Why did I start closing the brackets? No. Let's see. And here. Alright, now what? Aha, okay. Now did that work, or did I make up the idea that that would work? Let's see. Hold on, if I reverse, let me see. Why didn't that work? Unclear, but right. So we tested today, giving over another 30 minutes to structured effort. Now it's time for unstructured enrichment hour. Unstructured enrichment 2.5 hours or so. Alright, so I'm gonna, otherwise known as exercise and thinking out loud. Alright, so I'm gonna take a step away, and then when I return, I will exercise and think out loud. Okay. Let's change up the stream title here. Okay. Okay.
So it begins. Did that follow a pattern or did it not? I wonder. I consider. Well, it followed a pattern that is identical to itself. Yes, if each strike was recorded and given a timestamp, it is the case that that sequence of timestamps overlaps perfectly with itself. So when I ask if that collection of timestamps was a pattern or not, followed a pattern or not, what I'm asking is, as it were, is there a cheaper way to generate all of the timestamps than asking for a record of each of the timestamps? What do I mean by a cheaper way? Well, the idea, I suppose, is that I could say, yes, it followed pattern A. Okay, pattern A would be a finite collection. I'd say, if you give me was that a pattern? Well, again, one way. Well, you could come up with a pattern description in two distinct ways, notably. You could say it's pattern A, looped in times, or it's this list with order of patterns. It's 2 copies of pattern A, copy of pattern B, a couple of copies of pattern D. And that would be like if I played a measure in 4/4, then a measure in 8/8, and then a measure in whatever, in triplets. If I had different time signatures. Okay, but what am I thinking here? And this is deciding the phrasing, as it were, of these strikes. And so what point am I making? Well, so I could have a pattern in these 2 ways, or I could say that this followed a pattern with 2 forms of proof, as it were. Or 2 forms of assertion I could be making that have to do with what constitutes a pattern that is being followed. Which kind of pattern of these 2 available kinds? We have the 2 available kinds of pattern that there's 1 pattern repeated in times. That would be the most obvious case. And now our first point was that the case where we say the pattern is identical to the entire sequence, the pattern being identical to the entire sequence, well, that means that you say, yes, it followed a pattern. It was the pattern that tells you to generate that sequence. What does that mean? It means now, one way or another, that generated a sequence of timestamps, what I just did. On an audio recording, for instance, you could come up with a rule that would tell you where exactly on a time line to place a timestamp. So you follow the rule that you have. You follow the rule that you have for reading an audio file. And then you place a timestamp when the audio that's in the audio file conforms to your description. You place a timestamp at the position in the timeline where the audio data, which is like a spike, you read a spike out of the audio data. The spike has particular jitters, as it were, around a pattern or around a curve, you want to say. Okay, and I say the peak of that curve. Wherever a spike hits its highest point, wherever it's the loudest, wherever it has the highest frequency. Whatever rule I have a way of taking an audio recording with a timeline at the bottom and using the curve in the audio recording to decide where I place timestamps on the timeline. I follow my rule. This gives me a sequence of timestamps. And now when you ask, did those timestamps follow a pattern? I'm here saying there's maybe 2.5 ways, as it were, that those timestamps could have followed a pattern. Maybe 3 or even 4 ways. What do I mean? So we could say that the pattern I want to describe, well, I want to say what distinction is being made here. It's quite picky. We're asking, does this sequence of timestamps that we have gathered, that we have placed on a timeline, does it follow a pattern? And we're saying there's I don't want to call it a trivial case, but there's a set-aside case, it's a little bit trivial, where we simply say that the pattern is being this sequence. And now one way of pinning down what point I'm making here is that if we zoom in, if we fill out the digits of the timestamp, interesting. If we fill out the digits of the timestamp, we would eventually reach the point where only that description works. What do I mean? I have a sequence of timestamps on a timeline, and I'm saying if we could if we could continue increasing precision, if we could increase the precision, fill out more digits of these timestamp values, eventually the only description that will still obtain is that each of these timestamps is its own position in this sequence. Interesting. I'm not sure that actually happens. I mean, there could be other descriptions that don't fall away either. Okay, but how do you violate this description? What do I mean here? So, let me think here. Well, suppose I say I divide the timeline into, I have 8 timestamps that I place 8 timestamps down the length of the recording. Okay, now why did I do this? Not clear yet, okay. And now I show you the timeline with the 8 timestamps and I say, is this evenly divided? Have I evenly divided up the space on this timeline using these timestamps? Okay, and then the pattern that we would have exhibited if we succeeded at this is that the distance between each timestamp would be the same. We could go through each interval and compare their lengths, and they would be the same. And now my point is, that works so long as you can get away with rational values, or so long as you have rational values that have insufficiently many digits. Because if we increase the digits enough, we're going to find jitter relative to those 8th values. Those 8th values. Yes, well, in the ideal characterization, you'd say the timeline is of unit length 1, and each of these timestamps is at 1/8, 2/8, 3/8, 4/8, etc. And not at 0/8, I suppose. Okay, but then if I keep adding digits, I say Well, that's not an adequate description of this distribution of points because there's all this additional information about their distance from those specified values that pattern does not account for. What does that mean? Well, I look at one point at one timestamp and it's a little bit to the left of its 1/8 position, and then I look at timestamp 2 and it could be looking at any of them. Timestamp 6 over here. Okay, and the timestamp is a little bit to the right of its 1/8 value. Okay, and what am I to make of this? Why would one be to the left and one be to the right? If both of the timestamps were to the right, I could shift both of them at the same time, and then we would get our timestamp to 1/8 alignment, if you see what I mean here. Like, I see that I have two timestamps that are to the right of their 1/8 values. Okay. And now what I say is I'm going to shift these over. All right. Now what is the idea? I say I must have made a mistake in placing the 1/8 values. I needed to look more closely so I could place the 1/8 values closer to the true value. Okay, so that's the supposition we take. We have our values that we say are 1/8. We shift both of them to the right. Okay, and now they line up with both of the timestamps so far as we can tell. All right. Now, could be that all of the points, all of the timestamps were just that little bit to the right. Okay. And then if I picked up my wireframe, if I picked up my interval comb, and shifted it to the right, then I would get alignment between the teeth of the comb and the timestamps that I'd placed. Okay, and then it would have been an error in timestamp placement that we rectified by changing what constituted zero distance from the 1/8 value. Okay, now, but that's not the case we have here, where here I have my two comb teeth, and I have a timestamp to the left of one, and I have a timestamp to the right of the other. And now there's no way to shift the comb teeth to make both align. Okay. Now, so I say your pattern description is inadequate for explaining why these timestamps are located where they're located. Saying that you divided up the length into 1/8 and you put a timestamp at each 1/8 is clearly incorrect because there's no translation of this interval that allows me to capture both of these 2 points. Interesting. There's no translation of this interval that allows me to capture both of the 2 points. Okay, so now I say you need an additional description. Okay, you come up with another pattern. Well, you could go through and categorize all of the timestamp positions relative to the comb. And you could say timestamp 1 will be to the left of comb 1. Timestamp 2 will be to the left of comb 2. Okay, and this is the new pattern that you're asserting obtains of the timestamps. So if you gave me a description of the timestamps, and then I took the timestamps out and compared them against the description, I'd agree with the description at all points. Right. As opposed to our disagreement earlier, where you said I put them at 1/8 values, and I looked more closely, and that was false. Try again. Give me a different description. Now what is the idea? Well, you're coming up with this ad hoc continuation of the idea where you say, well, we zoomed in more closely and it turns out that you were jittery around your specified positions again. So you apply another rule that accounts for the jitter at that level of zoom. You say the pattern is everything I just said, but also when we get to those combs, there's this additional layer of rules that tell me about the jitter relative to the combs. And in this way, you keep constructing rules about distance from the comb or position relative to the comb so as to generate another comb tooth that at this level of zoom lines up with the timestamp, but might not line up with the timestamp if we continue to zoom in. Okay, now alternatively, I give you a pattern that the timestamps obtain. Okay, the pattern is that each of them is themselves. Oh, that's reasonable. Okay, and what do I do with this description? Each of them is themselves. Well, I want to perform this activity again of projecting the comb. Ah, interesting. So I project my comb onto the timeline, number line, whatever. I project my comb onto the number line, and I find out that my line doesn't line up with the point. Well, and that's like a mechanical failure, as it were. Okay, my comb doesn't line up with the point. And now I say what? Well, that can't be right. I mean, before, when we were talking about this iterative description of where the timestamp is located, where we kept sort of shifting our comb over, this iterative, let me see here. Well, in each case, we could say, well, our previous description wasn't refined enough. Our previous description wasn't close enough. There's something it captured, but it's the wrong position. If only this real value became a rational value, we would be right here. But the real value did not become a rational value. And on closer inspection, as it were. So now we have to account for the difference between the rational value we selected and the real value that is not equal to the rational value. Okay. Now, what is the idea? The idea here is that distraction, one moment. The idea here is that if you said your pattern was the point being identical to itself, as it were, now our projection, we have nothing to attribute the failure of our projection onto the point. What do I mean? Well, again, so when we were chasing down the real value by projecting the next position of the comb, we would zoom in on the point. We'd be able to see, not, I guess, know from the numbers, for whatever reason. We could see that the point fell on one side or the other of the comb. Okay. And now what is the point? And then we could extend the rules to say that in addition to the complexity we've already attributed to the comb position, we're gonna it's like we're going to add another gear to our machinery. Okay, it's going to look from here like our comb is projected onto the next point, or onto the point. When we zoom in, it might end up being to the left or right. We can't tell from this distance. Okay, as it were. Now what is the idea? Now you could attribute that to a gap between your description, which was finite in its length and doomed to failure. This alternative mode of description where you say the point is wherever it's at. Okay. Now, it would be convenient if we had that. I mean, if we had access to such a source of information. What do I mean? The point is where it's at. Okay. Well, and the idea is that I project a comb. In this process that I'm describing of projecting a comb tooth, projecting a comb is filling out the digits. It's giving me more precision, more decimal points on my number, on my rational value. So I am thinking. Now what is the idea? The idea is that when I say the point is wherever it's located, or that I say that this timestamp's role in the pattern, position in the pattern, is being itself, that gives me license to say I have infinitely many digits. But what do I mean here? If I keep projecting the comb, let me think here. It's like saying there must have been something wrong with the mechanism because there can't be anything wrong with the description. So I project a comb, and the comb is also following the description. The point is equal to itself. Okay, go to the point's position, which is the point that has the characteristic of being equal to the point, as it were. Okay, well, I mean, I have some mechanism that projects my comb towards that point, towards that timestamp. Let me see here. Let me think. It's interesting. There's something I can do here with an animation that I can't do with real numbers. Let's suppose. Okay. I can make a video animation of zooming in on the value of pi on a number line. Okay, how do I do that? I have a red point on the number line, and beneath it I have 3.14, and above it I have nothing, but there's 3.14 there. Or I have values above and below it. Alright, and then I slowly start zooming in, and the digits increase. Okay, the interval width, the visual interval width remains the same, but the numbers that are underneath are changing. Okay, and that's me zooming in. It's like the kind of film technique where you move the camera away while zooming in, as it were. Okay, and the point remains perfectly centered. So we're to infer that the value at the center is pi. It's remaining perfectly centered. I must have a perfect method for delivering intervals that continue to contain pi. How convenient that I have such a method. But what is it? What do you mean? Well, I mean, if I say I know where pi is, if I'm asserting that I could animate this in fact, I'm asserting that I have a process of delivering an interval that continues to contain pi. Okay. Now, in fact, we do have a process that could construct such an interval, and we could run it in real time, and we could have it play forward at the appropriate speed. So I imagine the process of filling in digits would slow down at the end, and you'd be reduced to calculating one next state after the other after you've gotten past all the memoized states, as it were. Okay. And so now we have a video showing where pi is located as a red point between two interval values. Alright, now, but here's what I do in my animation. I start zooming in, and then I keep speeding up. And I have as much runway as we have memoized values. Okay, I keep speeding up until the numbers are a blur. Okay, but you know that the blur of the numbers is still increasing in complexity, whatever that means. So I add a digit, but it's a blurred number. And that's because I'm moving through the numbers so fast, you see. That's what I'm trying to trick us into believing. So I start to zoom in on the red dot on the number line that represents pi. It's between these two intervals. The numbers start out as legible. I increase the pace of zooming in until the numbers are a blur. Okay, and then I just keep going. Okay, I just keep depicting the blurred numbers, I keep depicting the red point in the center, and I keep having interval bars. And that's all I have to depict in order to depict whatever would be depicted by such a video. Okay, such a video would be depicting something we can't currently do, notably, because after some amount of time, the blurry numbers would become unrealistic. We would be saying, you must have zoomed in to the trillionth digit by now. Or whatever, which no computer could do. Okay, but my video is depicting a computer doing it. Huh. Now, but what point am I making here? Or you might ask, when did my video stop depicting that? I think my point here is to make the bold assertion that if you assume you have access to the value of pi, it is like you're making such a video, which on examination turns out to be impossible. What do I mean? I say, I know where pi is, but I could never finish telling you where it is. And I guess that's what we do when we write down the symbol of pi. We could take ourselves to be asserting that we have knowledge of the infinite digits of pi. What point am I trying to get at with this idea? When we were talking about my comb approach to designating a rational value, we could look at the comb and we could look at the position of our point relative to a tooth of the comb. Okay, and we could say, in addition to this rule set I've just specified, I add another layer of rules that explain where this timestamp is located. Okay. You could try to supersede this process, circumvent this process, by saying each timestamp is located wherever it is located, as opposed to saying each timestamp is located where I project a comb, if you see my point. That's a strange observation. Well, we're projecting combs because we need something we can construct that can stand in for the assertion of knowledge concerning where the point is. We construct rational positions for the comb tooth. Okay, and then we say we're talking about the comb tooth, and we have sort of external justifications for choosing that placement of the comb tooth, or choosing that definition for how to deliver a comb onto the number line. Now, what is the idea? Now, but when I assert that I just know where the point is, I'm not saying, let me see here. Well, for some reason, when I write down the symbol of pi, that gives me a comb that's always on. As in, I can never zoom in on pi and find out that it's somewhere other than where I expected it to be. My projection method for the comb in the continuous case, in the real case, my projection method for the comb can't fail to deliver the comb. And yet then we don't use such a projective method for any computing purposes, I suppose, because I can't know where pi is, for instance. Okay. Now, so this is a kind of aberrant case where we say that each timestamp is at its own position, as opposed to saying that each timestamp is at a constructed position. I say each timestamp is at one of my comb tooths. Okay, though notably, we placed these comb tooths by... we constructed the comb that gathers all these numbers together. We did this by looking at spikes in the spectrograph. Okay, so we had an audio recording with a timeline at the bottom, and we had a spectrograph. Okay, and the point was that we had an analysis method. Now, we could say the peak of this curve is what I want to note down. Okay, and if I've noted down the peak of this curve, what am I doing with it? I'm asserting, for instance, I am asserting that the peak, whatever timestamp is associated with the peak of this curve, whatever timestamp is associated with the peak of this curve is a place in a pattern, a position in a pattern. Okay. The initial pattern we started out by talking about was the 8th pattern, where you asserted that you had found out where the 8th positions were and you had placed the timestamps on the 8th positions, which unhelpfully I took to be the assertion that if we continued to zoom in on the points, no matter how closely, they would continue to fall on exactly 1/8 along the length of the line. Okay, and then my alternative was to say, Well, now we're not going to talk about timestamps. Rather, we're going to talk about... Well, so the timestamps are going to be stand-ins for critical points in some kind of model we have for dividing up the timeline. Alright, but what does that mean? Let me see here. I'm trying to construct a kind of adversarial pattern where I can hear the continuation and I alter it slightly. So it always seems like it's going to settle into some kind of continued pattern, but it doesn't. And now again, we could say each of those timestamps that we could extract from a spectrograph correspond to, each of those timestamps corresponds to its own position in the pattern. Okay, and then alternatively, we group points up together. We group up points up together, right? Well, so there's a point that if you had continued along, right, okay, so we have the homoiconic pattern. The homoiconic pattern is the pattern that is itself, okay? This sequence of timestamp values is an exemplification of the pattern of being these timestamp values. All right, now a point is, I could loop that. I could say, we could have a compound pattern where that is the starting sequence and then it loops, it repeats twice. Okay. Now what is the point here? It loops twice, okay. And the point here is that, well, then we could intersperse it with other patterns. That we could call that pattern A, and then we could get pattern B. And we have pattern A, and we could get pattern B, which is distinct from that homoiconic pattern we were just talking about, and we could interweave them. Okay, and we could have 2 of the homoiconic pattern, then 2 of pattern B, then 3 of pattern A, then 2 of pattern B. Okay. Now, the other direction we could go is that we could subdivide a sequence that I generate into more than one pattern. So instead of taking that recording and looping it end to end, or instead of incorporating that into a sequence of samples that we give letter names, we go in the other direction, take one sample and divide it up into its timestamps, and we say that there is a pattern within this letter, within this interval, there's a sequence of patterns of letter. Well, I mean, we could do letter 2, 2 letter, 3 letter, 4 letter. And then what is the idea? Let's see. So one of these samples could itself be a sequence of A, for instance. I could have a pattern that I call A, or C, a shorter pattern. It's like 4, 4. and I loop 4, 4. Okay. And I do that some finite number of times, and that explains the position of every timestamp. Okay. And now one point here is that if I project the combs onto the timeline and we spot deviation, then we can attribute that to either either comb projection, problems with the projection method, problems with the description, or problems with the execution. So I am thinking. But supposing we could get it right for practical agreement, what I'm trying to do here is string together patterns. I'm trying to sneak in deviations from patterns in deviations from the comb. So I slow down a beat, okay, which is a deviation from a projected position. All right, I'm trying to pattern deviations from the projected position to get access to another pattern. But what I'm doing with that, when I succeed, is I'm shifting over into another phrasing. As if I'm in the midst of a phrasing that I should have started a beat ago, but I didn't. Interesting. So what? A comb projection. I'll be right back. Okay, Mac. Comb projection. I suppose the point here is that a characterization of pattern is a function. It's a set of ordered pairs between the integers. The which case counter, the case counter, right, we say the third, the fourth, the fifth, the sixth beat in this sequence happen on these timestamps or thereabouts, as it were. And then we project those timestamps into the distance. And our function is what we're referencing when we perform that projection into the timeline, deeper into the timeline. So I say, for instance, this is a classic case of phrasing dot, phrasing colon classical dot 90s. All right. So, because it is a classic case of, what did I say? I forgot. Yeah, hold on. A classic case of type. Yes, type colon subtype, e.g. Okay. Then, therefore, the upcoming, so the idea is that I identify that I'm in a pattern. I know what the pattern is. I use the instances that I have available to confirm that I am looking at the right pattern, or to narrow down which patterns I have to look at. And now I have to look at the upcoming beats. Okay, I've frozen time. I have to look at the upcoming beats. Okay, now what is the idea? The upcoming beats are about to be filled in. The next beat is going to narrow down the number of correct functions, going to narrow down the functions that can have been correct. Okay, so I'm going to have a function that references the upcoming beat, its timestamp. Okay, when the next timestamp gets filled in, what functions remain in my list? A shortened list, supposing any were filtered out. Okay, now, but at some point I say, I can name this sequence. It's a classical drum pattern from some country that has a drumming tradition, e.g. Okay. Given that it is that pattern, and given that we are at this integer step in that pattern, the next beat is going to be here at this timestamp value, instead of down here at this timestamp value, as it were. Or I guess it's positive or negative because it's deviation from something. I don't know, deviation from flat, unconditioned beat, e.g. Alright, so we say we have a metronome beat, and the way we designate timestamps is not by saying they fall on the beat with accent or with phrasing, but rather by saying that you're either above the beat or below the beat. Well, above the beat or below the beat. Above means that you fall on a timestamp value that's after the metronome beat, and below means you fall on a timestamp value that's below the metronome beat. Okay. And then we designate these phrasing patterns in terms of deviations from the metronome beat. They're sequences of deviations from metronome beats. Okay. now. So I say, I can read out of the deviation from metronome beat, I can read what pattern we're in, and I know what step we're on. Now I know how to predict whether the next timestamp falls after or before the next metronome beat. Okay. Now what is the idea? Well, now in a way this could be taken as a prediction. Namely, it's a prediction that when you give me the next beat, that pattern won't get shorn out, won't get removed. Now what is the idea? Right, a prediction that when you give me the next beat and I apply the rule, so I have a list or a set that I'm thinning out. Okay, I make a prediction for the next beat. Maybe my prediction is only, is it to the right of the metronome beat or is it to the left of the metronome beat? Okay. And then I'm thinning out my list on the basis of that Boolean question. Now I could be asserting merely that when you give me the next beat, my named sequence will not be removed. My specified sequence won't be removed from this list. Whereas when I have, well, okay, but the alternative assertion I could be making is that all of my upcoming predictions will be correct because I know which pattern it is. Okay, so as if to assert in all upcoming states, my prediction is already decided. I don't have to search through the list. So if I initially had a cluttered list, I might say, you know what, I bet this one is going to survive. I bet this one is going to survive. Okay, and so then I step forward, list contracts, it does not, and I say, my prediction about what function this was incorrect. My phrasing selection, my hashing selection was incorrect. Okay, now what is the idea? Now let's see. So then I have to make a new choice. So I am thinking. So I am continuing. I have to make a new choice about what sequence is going to survive the upcoming contraction of the list. Well, and because the point is that each time we get a new point, that's the occasion when we thin out the list. Okay, so we're going to get some upcoming point. I need to have made a selection in order to be right or wrong. Okay, so I make a new selection, and then you give me the next beat, and it's either thinned from the list or not. Okay, now if I know that I have if I believe whatever, that I have the correct phrasing, I'm not merely making the assertion that the upcoming beat, like I'm going to keep the upcoming beat. I'm making the assertion that whatever this sequence predicts that I currently have, it will be right until the end. Which is a different kind of assertion, I'm thinking, though I don't know how to think about that difference. And well, so the point could be, I have my list of sequences, okay? And I say, this sequence is going to stick around. Okay, why do I say that? Because there are general rules to beating patterns that we follow. Conventions, for instance. There's a conventional reason this sequence is going to remain and this other sequence is not going to remain. So we have our two sequences. I assert of one, this is going to remain because of this convention that we follow. This other element violates that convention, so it's going to be removed in the thinning process. Okay, now what is my point? Let's see here. Now, so I say, removed during the thinning process. Yeah, one moment. Right, so there I could reach a point where the upcoming beat decides convention adherence. Okay, and all of my samples will adhere to the convention, so we can thin out the non-adherent sequences from my list. Okay, now in such a case, when I say this sequence in particular is going to survive, what I mean is that this sequence in particular is going to survive. I need only be predicting that this sequence will be here in the next state. As in, this sequence will survive whatever happens with this beat because it adheres to the convention. Okay, but then I don't want that to be an assertion that I'm correct to the end. Like I'm hitching my ride to, I'm hitching my reference to, well, so again, I say a convention demands that the upcoming beat gets placed a certain way. Okay, I have a sequence that has that timestamp as it is supposed to be placed. Okay, I have numerous sequences that have that timestamp, all of those that adhere to the convention. They're all going to survive the Boolean check on the upcoming point. Okay, but there's a different class of sequences that will not survive the Boolean check. Okay, I just need to choose any that survive the Boolean check, and I'm fine. And then my record for correct selection remains intact. Okay, so that's what would motivate the interest in this foreshortened question. I could name a phrasing that works all the way to the end, but I maybe don't have to. Or I don't know yet, but I can nevertheless choose a sequence that is correct for the next beat and stick around to make a more informed choice. Well, the point would be that this is a distinct event. I lock in. I recognize a sequence that will survive the next beat. I might have to do that every step for several steps. Okay, I correctly guess the convention, as it were. I correctly identify the convention adhered to. Okay, but then at some critical step, I say, nope. I now know which phrasing this is. So, however far we keep going, this sequence will survive. So I'm saying that reaching that conclusion is a distinct event in investigating these sequences, where you know the correct sequence, and therefore you know its outputs will align with whatever is in the whatever's among the actual beats. Okay, so you have this juncture where you lock in your knowledge of what pattern is being played, and then you have a certainty you didn't have before. Well, you're making an assertion you weren't making before. Before, it would have been gratuitous to make an assertion that but you could, because you selected any sequence that survived. Okay, that sequence goes all the way to the end, which is to say that it makes a prediction for every beat all the way to the end. So purely mechanically, you could continue feeding this sequence into the function, even if it's wrong. But what do I mean? I mean, interesting. Let me think here. It's a strange point. So we're talking about the next beat, and we have sequences that either survive or don't on the basis of the placement of that beat on the timeline. Okay, we're going to have a contraction of the list or not based on whether a sequence survives the beat or not. Okay, and now the point is, if the sequence has survived to this position, I can take the value out of the front of it, which is a prediction for where that beat falls, and see whether it's correct or not. Okay. If it is correct, there will continue to be elements. So this is an assurance that any list that falls out of this contraction process, any sequence that falls out of this contraction process still has an element. Huh. And what is the idea here? The idea here is that we're not going to try to take a prediction out of an empty sequence. I don't think that's quite the point. Let me see here. I'm trying to get at this point that we have sequences that will survive this convention point. There are sequences that will there's one sequence that will survive this convention point because it is the phrasing that is actually being played. It is the correct sequence. Okay. And then there's a host of other sequences that will survive, a class of other sequences that will survive merely because they adhere to the convention. And then there's another class that will survive will be thinned out because they don't adhere to the convention. Okay. The convention for timestamp placement. Okay, so the idea is that each of these sequences predicts whether the timestamp is placed before or after, whatever ordering you want here, before or after the metronome beat. Okay, which we modeled as being above after the metronome beat, greater timestamp value than the metronome beat, or below a lesser timestamp value than the metronome beat. Okay, so now there's a convention across sequences where if you've just had that pattern that we encountered, you choose less than on this beat. And now there's some sequences that choose greater than instead, and we say those don't adhere to the convention. That's why we thin them out. All right, now, so the two classes that will survive, one has only one member, and it's the correct sequence. The other class will survive because they adhere to the convention. Okay, now what is the idea? Now, so when I don't yet know which of the two, when I can't yet identify the correct sequence, I can get away with choosing sequences that adhere to the convention. Supposing I can identify correctly the convention that is going to be present in the upcoming beat. Okay, and then what is the idea?
Hmm. Why did we want examples of multiple cases that would survive a filtering criterion in this example? The idea of not yet knowing... well, the idea of separating out these two kinds of correct choice. Where we'd want to say that knowing the correct sequence that is correct all the way to the end is some kind of increase in knowledge, whatever that means, over merely knowing a sequence that will survive the filtering criterion. Certainly, we would want to think of one of these assertions as being stronger than the other. I know which is the correct sequence, as opposed to I know a sequence that will survive the filtering criterion. I suppose the point is that if we continue the sequence long enough, the filtering criteria, one after the other, will winnow sequences away until there's only one. And that will be the correct one. Okay. I guess this would be true even if on continuation of the winnowing criterion, we eventually winnowed out the last sequence. We could just say whichever was the last sequence to survive the winnowing process, that's what we were looking for. Though, what if you had two sequences and both of them failed to survive the winnowing? Interesting. I don't know what winnowing means here. Yeah, we would need to know the particulars of that, the implementation details. But okay, in the easier case, we always get one last sequence. We have a last case of a sequence getting winnowed out by application of stricter rules for our sequences, and whether or not continuation of those rules also winnows out the last case, we nevertheless had a last case to reference. So we suppose. And what is the idea of this? This is a way of... So this is what we would designate as the correct sequence. And the reason we would designate it as the correct sequence is that if we had chosen any other sequence, it would have been thinned out by the filtering criterion before that juncture. The filtering would continue, but we would not be able to watch it because we had chosen the wrong selection. Yeah, that last bit of verbiage is kind of rough. Okay, well, no, so what? So we have this sequence that has survived all of the rule applications up to the final juncture. Okay, and that's what we call the correct sequence. If I had chosen it earlier in the process, then when you asked me, well, if you asked me which sequence are you going to choose, I would default to saying this one, because I'd already decided that I had the correct sequence. Whereas, if I don't already have the correct sequence, or if I don't think I already have the correct sequence, I might jump around between sequences. I might hold on to a sequence and then arrive at a convention juncture and say, oh, oops, this one does not adhere to the convention juncture. Or rather, this does not adhere to the convention present at this juncture, so it's going to get filtered out, so I have to jump to a different sequence. So then I have to say, well, I can't default to the answer of saying this one. I stick with this sequence, because I might have to jump.
Okay. Now what is the point here? Let's see. Well, that's an interesting difference at any rate. It's an observation about the difference in our status, as it were, between whether we're asserting knowledge of the upcoming beat or if we're asserting knowledge of having the correct sequence or asserting knowledge about which is the correct sequence. Interesting. Now, in the beat example, we can't have any sort of by the book patterns to point at here. But we could use musical examples here to say that this winnowing process is going to winnow down into a genre and then into a niche and then into a performance would be an observation. What do I mean? So I say I know what the phrasing is. It's classical. Okay. I hear a classical beat. Suppose. And classical could mean anything here. Yeah, and I don't need any particulars for the types. I'm merely observing that if it's distinct enough, then after one winnowing, we've gotten rid of everything that's outside of the genre. And then we perform another winnowing where we tighten the rules. And then we have fewer samples. Okay? And they're getting closer and closer together. I don't know how to prove that they are getting closer and closer together. It could be that you could have substantially different phrases that nevertheless both survived a rule application. Like if I said, when I say classical, I mean follows this rule list. A classical phrasing follows this rule list. Okay, it turns out you can have something that sounds nothing like a classical phrasing that also adheres to this rule list. Like, for instance, if I merely outline a phrasing, you could instantiate that phrasing and then fill in the gaps between pitches with 1,000 additional beats, for instance. Just throwing out the idea there. And what is the idea? So you have the classical pattern sort of embedded into a sequence that is more intricate than the classical pattern. And you do this embedding in such a way that when I read the rule list about classical patterns, it also obtains for this clearly non-classical pattern. Okay, and then I tighten the rules. This narrows out some of the classical samples because they're not close enough. It's like we are in late classical period, I say. Okay, so we winnow out all of the early classical phrasings that were similar enough because they were the same music, for instance. You could have the same piece of music played at late classical as opposed to early classical because pieces stick around and get re-performed. Okay, in that case, you would have the same beats, for instance. So you'd have the same mechanism in place for talking about phrasing. But what do I mean? What I mean by same mechanism in place for talking about phrasing, you would have a classical piece. It's not only classical pieces that can exhibit classical phrasings, but every classical piece exhibits classical phrasings. So if you have a classical piece in front of you, you know that it exhibits classical phrasings. Then your prediction or your assertion about which classical phrasing will have a valid substrate, a valid object of reference. You play through the piece or read through the sheet music, there are going to be samples of those phrases that you want to reference. Okay. Now, so I say this is a late classical form of the phrasing based on my reading of the falling relative to timestamp, or falling relative to the metronome beat. Okay. Now, it winnows out the early classical, but somehow it doesn't winnow out this entirely separate, obviously non-classical piece. Okay, and we keep winnowing down and we keep having these two that are so different from each other somehow. Now, is that possible? I don't know. It probably depends on having more context than I've provided in this discussion. But okay, if we ignore this aberrant case and we only look at the classical pile, okay, I'm tightening the boundaries. So this is the idea that I wanted about tightening the boundaries. We wanted to say spatially you could think about early classical and late classical phrasings as being close to each other according to whatever criteria we would use to compare them. And then if you had something out here, that would be like late Baroque, okay? Where there's a sort of gradual transition towards classical. Okay, so you have late Baroque, and that's similar to early classical. Okay, and then some kind of metal music is not so similar, or whatever, pick your genre. Folk music is not so similar to classical music. Okay, but then we have this curious case where that spatial dimension doesn't work. We can't use the spatial representation as a proxy for talking about similarity, conceptual similarity, or phrasing similarity, because there's something distant that continues to survive the constriction of the rules. So we're narrowing down around this phrasing, but apparently we're also narrowing down around this strange outlying performance. And maybe there are nearby performances out here as well. Now what is the idea? Well, again, if we ignore that case, okay, then if we ignore the case that's over there that defies our description of getting closer to, then this is what getting closer to means. It means we're constricting the cases around one of these samples. And really what it's saying is that if I keep adding rules, then one of these sequences is going to survive and all of the others are going to leave this region. We're going to thin out or tighten up around the one surviving sequence over here, and then we just don't care about what's happening over here with this sort of bubble that's somehow also generated by our function. As it were. Like somehow the numbers in this region, the sequences in this region are still adhering to the description, even though we were initially motivated by this sequence, which now has nothing around it. There's some other central sequence over here that's still surrounded by a region, has survived all of the constricting rules, and still has an area. So we could extend our rule set even further and check whether this last classical sample survives, and at the same time find out if the central sample in this region also survives. Interesting. So we would continue tightening the rules around the last sample over here. Last sequence. Okay, then what is the point? Let's see. Knowledge that I have a sequence that will survive the next narrowing, and knowledge that I have, or belief anyway, that I have the correct sequence. And what this boils down to is knowing that I can continue to, well, so each round, as I'm imagining it, each round I have to choose a sequence. Okay. And I want to say each round, I can default to saying I choose whatever is next in this sequence because I have the correct one. How could I know that? Well, so our booleans that we've allowed ourselves for this winnowing process have been above or below. Okay. And elements were winnowed out by saying we predict above, or rather, the next element in the sequence will have to be, well, so like convention, for instance, we say by convention the next element is up. So anything that has a down element, any sequence that has a down element is removed. Now, what is the idea? The idea, let me think here. We're removing sequences. I'm dropping my idea. 1 moment. We remove, now I'm dropping grammar, we remove sequences. Let me think here. Dropping ideas. No good. Let's see. So we're wondering, how could we know what the correct sequence was if the only truth of the matter is whether the actual timestamp falls above or below the metronome beat? Because all of the same, well, the point would be the first false case, the first case where your prediction disagrees with the actual, you shed that sequence. So we have actual down and sequence up. That sequence is gone. Alright, so every sequence you have has been correct with regards to every timestamp placement. Now, that is by no means to say that they're equal to one another. You could have, for instance, a sine curve that's shifted by, that's translated left and right phase shifted. For instance, where there are varying steepnesses on the sine curve. Let me think here. And the point would be that you could be out of sync with the sine wave, but it would nevertheless give you the correct values each time. It would give you the correct values for a finite number of cases. If you have points that are lined up with a sine wave that has a shorter period, eventually you're going to get a point that's on the one sine wave and was above and now is below. So you go the same distance again, and now your sequence predicts up, but instead it's down below the other curve. What is that trying to say? So the point here is that being in agreement, having all of these sequences produce the same up value or the same prediction is no certainty, no guarantee at all that they're the same, because you could have infinitely many sine curves that, like what I just described, where they position points in such a way that they all agree up to a finite number. You could have a set of sine point placements that all agree up to a given position where one of them would disagree. Some first of them would disagree concerning whether you're up or down. Okay. And the point is that... Right, so I have a set where all of them have agreed up. I have a set. Each of them is a sequence. Each of them predicts up or down, above or below. And every element that's in that set has survived the process up to however many iterations of the process of winnowing down. Okay. And I say they're not equal to one another. They don't have to be, therefore, equal to each other. Okay, but what is the point of this observation? They don't have to be equal to each other. Right. But that's also the only information we have. Seemingly, that's the only information we have. What do I mean? Well, there would need to be some additional information, so I suppose. There would need to be some additional information we could access in order to explain why we would choose one sequence as opposed to another. If every of the surviving... Well, as we have agreed, every of the surviving sequence has reached the same conclusion about each next status with regards to the metronome beat. So there's no way to differentiate them. They're all in agreement concerning the up-down sequence. So we would need some additional way to differentiate them in order to reach the conclusion that one of the sequences is the correct sequence. Okay. Now, if the status prediction was a derived value, as it were, what do I mean? A derived value. I mean that we could have a timestamp. So this is the metronome beat on a left-right. This is our metronome beat. Okay, and now we could retain the ability to differentiate values that are on the same side. Up to this point, we haven't needed to. The only characteristic we cared about was whether a point was to the right or to the left of the metronome beat. Okay, but now instead we're saying that we can differentiate between them on the same side. There's some additional characteristic. Well, what you'd want to say, for instance, it's more digits. It's more digits. We have more digits than are required to determine whether we have above or below the metronome beat. And we use the information that's encoded into those digits to compare points, timestamps to each other. Okay, and then there would be a pattern in the constellation of... Well, there would be... Let's see here. Well, so for instance... no, I'm not sure. Let me think here. I mean, how would we reference timestamps in order to justify the selection of one sequence over another? Like, we have a cluster of timestamps that are all on the same side of the metronome beat.
how am I comparing them to each other? How am I comparing them to each other in order to justify selecting one of them? Well, it's like you'd want to say, I'm listening to the recording while watching the spectrograph, and I just know. I'm listening to the recording and I say, yes, I remember this phrasing, even though I haven't heard it. I remember this phrasing, yes, this is late classical. Alright, so I say late classical, definitely. Okay, and then this pile over here, like the student brings me a recording into the piece of sheet music. And I'm listening to the recording and I say, oh yeah, that's late classical. Okay, and the student says, thanks. Okay, and what happened for the student there? There was this huge pile, the classical interval, and it didn't occur to the student in forming this categorization just how many different sub-niches of the classical period there were. Okay, so the student wanted more narrowing down. And now when I say, yep, that's late, I say that's classical. Student says, yeah, and I say that's late classical. Okay, oh, that's late classical. All right. And now the number of upcoming sequences that can agree with the characterization I've provided has shrunk. And there's an intuitive meaning to this observation as well. What do I mean? The intuitive meaning to what description I've just provided is that when I say that's late classical, okay, if I say that's classical, you could have the play could continue in either early classical or late classical or anywhere in between. Okay, I say that's late classical. That means, well, as if there's some point where you would say I'm wrong. I don't know where our boundaries are with regards to what constitutes late classical. But if I say that's late classical, and you say, no, I mean, that's like 2 years before the end of the classical period. And then I say, yeah, that's late classical. And you say, no, I mean, the classical period wasn't even that long. And then we just have a disagreement about terms. Or I say, that's late classical. And then you say, that's like 2 years before the end of classical. And I say, no, that's like a month after the end of classical. Okay, and then we can change up what it is that we were disagreeing on. We might disagree about when the classical period ends. We might ultimately be disagreeing on what time this sample came from. Okay, we have different beats in mind, though it's not clear at what juncture we begin to agree about that question. We might be thinking of different phrasings, and then the pattern is going to prove one or neither of us correct with regards to which of the phrasings was actual. Now, what is the point here? The last sequence to survive a winnowing process. So there would need to be... We would need some kind of criterion for selection beyond the Boolean status with regards to the metronome beat. It's not merely above or below that would be informing which sequence we call the correct sequence. We would need some additional dimension of differentiation for points that fell on the same side of the metronome beat to say that one of them is the correct sequence and all of the others are not. Interesting. Well, okay, and that's... It's kind of... there's a... let me think here. So you could have different eras of phrasing where they all adhered... I mean, sort of arbitrarily... So suppose you have a Boolean sequence, and again, this Boolean sequence is merely... Did the phrasing beat fall after or before the metronome beat? Okay. Now the point would be that, as it were, you could have arbitrary... Well, no, hold on. No matter what Boolean sequence you have, that doesn't force you to winnow out different eras. You don't have to be winnowing down in only one region. You could be winnowing down in more than one region, so we're imagining. But what does that mean? Well, so if I only say the sequence is below, above, above, below, above, you could have additional patterns embedded into whatever additional patterns means here. You could have additional patterns embedded into how far away the beats were from the metronome beat. Okay. You only have to satisfy the Boolean description, and you only have to satisfy it for as many beats as we're checking. And now again, the point is that you could have additional information about the phrase that's encoded into distance from the metronome beat. So these two different phrasings would survive the same Boolean chain, but there would be the additional information of distance from metronome beat that allows us to differentiate them. Okay. But so you could have two classical phrasings that disagree on the Booleans, but were otherwise similar to one another, as it were. Like there's one critical point where if you look really closely at the metronome beat, one of the classical phrasings goes on the wrong side of it. Whereas then you have a different genre of phrasing that happily adheres to all of the beat placements, happily adheres to all of the Boolean description, even though it's not similar to the other sequence that also adheres to the Boolean description. Huh. Sounds like I've just described something interesting, but I don't know what it would be. So we had the sort of chaotic patterning of, we could do another sample of that. So it's like there are these points where I can
delay and stay on the correct side, it's like I'm stitching together patterns by moving. So I find patterns that on a given beat both fall on the same side of the metronome beat. So I'm following a pattern up to here, and then there's a new pattern that I want to begin. So I delay. Well, actually, it should be above and below. No, yeah. I delay up, and now that's close enough to being an instance of this right pattern, and then I carry that one forward. And so there's this kind of overlap frame where I'm within range of both of the patterns, and both of the patterns are falling on the same side of the Boolean line. Whereas I could have a case that they fall on different sides of the Boolean line and they're far apart, but I could also have that they fall on different sides of the Boolean line but they're close together. Interesting. Okay, so I wait for a case where they're on the same side of the Boolean line. Okay, and they're close together. Then the beat that I choose is an instance of both. An instance of a variation on both, I suppose. And then I can carry forward the sequence. Interesting. I'm gonna take a break. Right back. Alright, and what was that idea? I don't know. Alright, I might study opening theory for a little bit. What do I mean? my body is failing on enough fronts that I'm gonna take a break. Though also, well, I mean, I haven't done as much. This was not as activity-packed as it often is. Well. Alright, and then what? Opening theory. Yeah, let's see. Yeah. Let's see. Play bots. Nope. I resign. Let me see. You bought. No, that's not what I wanted. I wanted to choose. Here we go. Takebacks, yes. Standard. Okay. Yeah, well, I mean, a point here is that when we were watching the World Chess Championship, we had, well, we could ride off of the efforts of the players in having good openings. Okay, and then if you already start with a good opening, then you just have a good continuation with the F pawn. Like as if with any given opening, there's some best way to play with the king pawns outside of letting them sit, if you insist. Okay, so I can start with a good position and then start playing with the king pawns in that way. There's no pressure on this pawn. However, it supports this advance, and if that's going to be the advance, we'd rather have the bishop on the other side of it. How do I stop an advance like this? I could dissuade it with a knight, though. I don't know if I want to commit to blocking the c-pawn. Yeah, it's like I want to get out of the opening. Actually, hold on. I don't want to commit to e4. Alright. Let's just see if this works, see what happens. Oh no, right, we have to play the F advance. If we're going to try this. Okay, which does not support this advance. If you'd played knight...
Hmm. Light squared bishop also has eyes on h3, so we can't... Well, and we also gave up the option of supporting knight through h3 with light squared bishop. We could argue that this is good. And then I suppose the idea is h3, bishop takes, g takes, king f2, queen g1. Uh-huh. And then this advance. Well, this advance takes, so that's also stripping the king structure. Well, and during all of this, we're not talking about the knight participating here. Yeah, and I'm not so keen on... Well, that gives the queen a place to be. Well, so we could also play knight back to f2, which plays... So if knight h3 and doesn't take, knight h3, knight f6, which supports the advance. Okay, then we could drop back. Okay. And if you advance anyway, takes, and you're down the piece, or rather down the pawn, pawn takes. We still have the dark squared bishop block. Let's see. This also, though, is coming with, yeah, So we could play c3 with now option to drop back in the event of advance as well. Okay, now we could cover that with queen e2. We could also cover it immediately with king f2. I'm a little bit wary of that move because I like king e2 in some circumstances. This has also opened up the queen, incidentally. Don't know how interesting that prospect is at the moment. The idea of here... And then I suppose we have the option of bishop b2. Like knight e2. In the meantime, this needs to be covered. Yeah, though what we mean by in the meantime is that... Well, so if I use queen e2 to cover, we're not going to have knight e2. So I guess what I'd be looking for is queen f1, but that's really inefficient. Like king f2 and then queen f1. Though we've already opened up this diagonal for the queen as well. Yeah. If I play king f2, bishop comes out, and I develop the knight with tempo against the queen, bishop takes, pawn takes. Well, I could also actually go for the h4 advance and get that in. And then the rook is actually, yeah, that makes sense. The rook is happy where it is, supporting the h advance. King is on f2. And queen is looking to go to g1, and knight is looking to go to e2. In some order. Hmm. Yeah, hence having e4. Though. Not an available resource. Well, unless I'm willing to play this, but maybe I am. Okay, well now probably the most salient question is where does my king want to go? Well, I mean, I feel like king c2 is going to be pretty safe. Queen is off color. Don't know what this knight's up to. We're not up material, no, but we are up king development, queen e1. I want to get this knight off of the edge of the board, probably. I probably want to do that with knight f2. I feel like my pieces are lacking in harmony at the moment. Play rook f1 with the idea of pushing f with knight support, bring the activity out of the knight. This would also open up diagonal for the queen. It will open up this knight g4 move. Well, supposing the knight hasn't moved on since then. This advance takes is tactically relevant. I'd say it's a little bit suspicious. Yes, well, that's part of why we want to retreat the knight. Yeah, though then nothing to cover h. Queen b3 is available. What does queen b3 do? Yeah, well, castle's queenside. Yeah. Knight is covering f7, so if this advance, we don't have winning pressure against f7. We could finish castling our king and say the knight is not our main concern here. Well, yeah, so we finish castling. Oh, maybe we could be swinging the dark squared bishop around. That makes some good sense. Alright, though I feel like I've made too many pawn advances now. Okay, my opponent gives me the opportunity to get my knight off the edge of the board and out of the way of the h-pawn. I think I will take that opportunity. So I've blocked my king actually, so it would have been an option maybe to play queen e2. I looked at that move over and over again. It would support the immediate knight f2, which would be the justification. But I kept looking at this diagonal and saying d1 to a4 is good. But now the king is blocking it anyway, so maybe I should have played queen e2. But at any rate, my opponent has dropped back and denied or gotten rid of this pressure. Alright, so getting my knight off the edge of the board seems like a good move, but then so does this. I don't have any counteraction against the g advance, is a point here. I don't have any counteraction, so I'd have to get my knight out of the way and advance the h-pawn if what I wanted to do is apply counter pressure against, against the g advance. And otherwise, the pawn advancing, my knight doesn't apply enough pressure. You can also back this with a rook because castling queenside is even recommended here. So rook could support the g advance. Queen currently supports the g advance. You can't drop knight back to f7 to support the g advance. Alternative, we play the d advance. Yeah, I mean, given that this doesn't stop the pawn, we have no pieces that are participating, and this is another pawn move. Yeah, though it's, yeah, but I mean, yeah, these piece development options are also kind of slow. We could play g3, which opens up knight a3, I suppose. Bishop b2. We don't have a follow-up move for the knight without access to c2. Well, we'd have to be advancing this pawn, which seems unlikely. Advancing the g-pawn. And then advancing the a-pawn. Wait until my opponent castles, advance the a-pawn, and say, I need two I need two minor pieces to defend my king, please. I'm requisitioning two minor pieces to defend the king. Maybe the queen sticks around on d1 as well and supports the d3 advance. Queen is also supporting here. And then actually this comes with tempo as well. Also denies this move, which might be awkward. Forces me to play d3, which I haven't signed up for. Though actually advance and then, yeah, there's no here. So advance and instead you play here. Interesting, okay. Then I probably have to follow up with d3. I don't know if I've put myself in a better position then. Yeah, so advance over d3. Well, and then I would want the knight on f2, I suppose. I mean, this comes with tempo, but then this also comes with tempo, with check. And then at that point, advance d3 to block. And then, let's see, advance. Yeah, and I have no pieces covering this, so this would be our opportunity to get the knight covering this, I suppose. I've claimed this victory of getting my knight off the edge of the board first. This capture's fine. Well, actually, this just hangs a pawn, but then why is my 2000 expert opponent hanging a pawn? Is it though? Pawn is pinned, I see. Well, so queen e2, which is already reasonable. There's also queen g1, and we get two heavy pieces behind these two pawns. Though then I don't have a defender for this pawn, so actually no, that doesn't work either. I'd be hanging my pawn. Yeah, I don't want to do that. Queen e2 opens up the back rank. We could also pose this question. Well, queen e2 and we're threatening to take, and then knight takes with tempo against the queen. So queen e2 takes. And now the G file is open. Yeah, but more importantly, I'm also free to play D3. Okay. Making the observation that if I advance takes is awkward. Knight covers rook, queen covers knight. If I take, knight takes, exposes queen to G2. But you cover at the end. Takes. Yeah, well, you can't play queen takes, you have to play pawn takes, interestingly. Yeah, but I still can't capture at the end. True enough. Though I could then develop in this direction. If I advance here, takes in this direction, we can recapture, advance, queen takes, takes, pawn takes, pawn takes. No, what we're thinking about is this. Takes, and then takes, takes, and now takes. I don't think I'm unhappy about this structure. Mm-hmm. This has left this pawn. This way of resolving has left this pawn. Follow-up knight move through to b3. Or bishop d2 to e1. This is the b3 option to open up knight a3, but I'm not sure for the... I don't know, maybe we're playing here. I doubt the king has enough support to do that. I'd like go for the H advance and then play knight a3 with rook support. Is also following through the H pawn and getting the activity out of this rook while it's here. I mean, we could kick the queen off of this file to reactivate the knight. By what juncture would I need to reactivate the knight? Well, this is a bit of a problem, isn't it? Though, notably, we could respond to that with rook support for the knight. And then we have rook on pawn. We could also advance to deny this square. And then the knight can jump. Let's see. With queen support. That doesn't feel so good, though a lot of the squares you'd want to go to are denied. If I advance and you challenge the knight, I'd have to keep the king in defense. Well, I could slide the rook over again, and then the idea is that we're playing king b3 to get out from in front of the... yeah, but there's another problem here I don't like, which is that the queen also has... So even if I get in b4, I still have to worry about the queen. I'd have to be able to... Yeah, so I'd have to be playing... Well, I could be playing knight a3 with the... that's interesting. So, advance, knight challenge, rook over, knight takes, rook takes. And now there's a pin on my rook. And I'm looking to get out of it by playing king b3. Okay, and now... if you play the queen over, what I actually don't like here is that we're allowing a trade of pieces. That is undesirable, but I also don't want to wreck my own pawn structure advancing to block the queen pin. And actually, this advance isn't so good for me either. But yeah, we'd be trying to get the king off of this diagonal by advancing to b3, but then queen e6, and you get the pressure down the diagonal. Though actually, a point there. That's interesting. So b4. Let's suppose you play this immediately. I block, takes. Alright, so my rook is on d3. Okay, and now you castle, let's suppose, and I play king b3. Now you... No, we need to... You castle and I play knight a3, and now I'm threatening to play king b3. I don't know how I would render that. First point, you castle, and then I play knight a3. And now the idea is that I'm threatening to play king b3. I'm threatening to play king b3 because if you play queen over, I play knight f4 with tempo against the queen. And if you advance first, I play knight c4. That might not end up working though. There are a few reasons that might not end up working. I don't have bishop d2 in yet is one of them. And if I played f4, okay, and then you play, let's suppose here. Now I'm gonna play this kick. Okay, you don't have winning pressure against e3, and you can't go here due to the pawn pressure. So you go back here, and now your dark squared bishop is cut off. Though I've also lost control over this square. Yeah. And I advance again. You claim this square. I guess I'm supposed to ask, what is that square going to do for you? Yeah, but I can also maneuver my dark squared bishop. And the idea here is that we get the knight back into the game. Well, I mean, we want to play this advance because we want to deny this trade offer. We've already shut down the knight on this side of the board. We don't want to allow black to wriggle out of this knight, particularly this bishop e7 move. You're running out of squares to go to. You'd have to traverse the back rank or find something to do with a5, which is implausible. If you went to a5, I'd happily play b3 as well to keep you locked out. So I think we might have to go for this advance. Have to, whatever that means. You could offer the queen trade. That's a little bit awkward with knight support. Well, and then if I do take though, and then you'd have to go back to, yeah, we've already decided that's not a bad outcome because you can use e4. We could at that point also play knight back to f2 to deny access to e4, along with knight d2. I also, though, don't have bishop d2, because then I don't have a defender other than the queen. Same idea behind knight d2. We need rook d1. Though another way is getting out of the pin. Though, okay, but now we're advancing this pawn. We don't have this knight support, and we're advancing this pawn into bishop and knight pressure. True, I mean, it helps that bishop d2 defends. But then maybe we need to play that move, but again, we can't. Deny, and the bishop back to e1. We have this structure. We go for this advance at some point. We can get the bishop behind. Activate all the pawns over here. And in the meantime, bishop bishop d2 will be covering this if we want to make that advance. Like if the opponent castles queenside, the pawns on the queen side. Well, you're gonna have the king blocking out the two heavy pieces. would be the most critical point, I think. You have king on c8, preventing the rook on d8 or the rook on h8 from activating against my queen structure, in which case you're going to have less force to bring to bear against my queen side, which also makes it easier for me to make advances on the queen side. So now we have bishop d, well, we have the denial on knight e5, then we have bishop d2. Yeah, I don't want to agree that the f advance was wrong, though. That is difficult to maintain. No. b3, get the rook into position and play king to b2 instead. Yeah, then we have a lot of pawns in the third rank. Yeah, the rook is off color and the knight is not threatening to kick the rook from d3. So plausibly this isn't a problem. Okay, now I could immediately break the pin. Okay. Oh, I kind of like that, but yeah, well, I mean, the problem remains we want to have access to rook d1. Well, I mean, we could claim that we're going to keep that access and go for a4. I mean, my opponent's already spent a tempo moving rook towards center. We could also preemptively play this rook move, but we have all of these squares for the rook. So many squares. Why would I drop the opportunity to choose alternative squares? Yeah, I mean, I also want to claim... Bump the microphone. I also want to claim b4. I suppose with queen support. Though, how convincing of support that is, I'm not sure. Okay, and the claim on b4 is that... Well, so I could play knight a3 here, and bishop takes is not compelling. Okay. Because of bishop takes, which would then also deny castling. So if not captures... Well, then maybe I'm playing b4. What's the connection? Right, well, I've prepared knight c4. Okay, so knight a3, and then if you play knight e5, obviously, yeah, I still have to cover with rook, but now I advance b. Well, yeah, let's clear these arrows, though, because that's always the case. Right, so I can break this pin. I'm playing b4, and okay, and the idea is that my knight over here can interpose. Yeah, but it can't though, because you also have to have the A advance. Maybe we want to claim the A advance. Well, because the knight on a3, what is it doing? Nothing. It doesn't stop the a5 advance, for instance. Yeah. So we would need this idea of getting the king to b3 and then queen e6, and now the advance I can meet. But I can't secure that idea because I can't... Well, actually, we could counter advance. That's interesting. Supposing we had my bishop on d2 as well, we'd have bishop knight and... Well, that might assume something about... Yeah, wouldn't the bishop be happier over here? Yeah, well... let me think. If my bishop is on d2, then we could be going for the counter advance, if you advance. Where bishop and then king... Yeah, this is requiring a lot of extra piece moves, though. Where are we getting those extra piece moves from? We're not claiming Tempe. And this thing sitting on the table is forever bothersome. Okay, alternative idea. Bishop b2 and knight d2. And maybe we would start with knight d2. What do we get out of this idea? Maybe. The opponent doesn't have any support for this, and after castling, the rook arriving on e8 is blocked by the bishop, so you don't have rook support for this either. Queen supports e3, though you could get... Well, you can only get one piece, though. We can also move the knight again. I'm not sure how we would move it. Maybe we're advancing here and getting the knight behind g4. Dissuade a counter advance. Maybe a lack of harmony with my other pieces. Maybe if my bishop was going back here. My bishop were on b2 to start with, and you advance, takes. We're fine, right? Well, I think we could plausibly be fine even without the bishop support. Advance takes, knight takes, rook takes. I mean, I'm stripped, but I'm not out of the game. Whereas, well, okay, but so we could dissuade this advance. Well, yeah, so I mean, advance and then bishop b2 takes, bishop takes. And then I guess we're leaving b2 for the king. or advance takes. Advance, bishop maneuver takes, bishop takes. We still control the knight. Well, and so the point is... Wait, what if you do this immediately? Doesn't that remain a problem? We could also keep the bishop on c1 with the option of dropping back through e1. Or staying on d2. Yeah, breaking the pin on the knight. I mean, this move isn't much, I think. I don't think that's going to be so persuasive. Claims tempo against the queen, but why does my knight want to be on f4? It's difficult to protect that knight, prevent it from getting kicked. Actually, is it though? So like king b2, and we have the idea of playing knight f4. So let's say king b2 castles. Okay, and then knight f4. What is this accomplishing? Let's see. We get pressure against that d-pawn. If you play something like queen d6, covers the pawn. My knight is also out of the way of my queen, interestingly. King b2 also preparing a different line with knight a3. Actually, it's interesting, you can play knight a3. You can play knight a3 and then play king b2. And both recaptures work, so I like to imagine. King b2, so knight a3 castles, king b2, bishop takes, king takes. Alright. And now the idea is that the king is supporting this advance along with knight. Though, in the meantime, what is this knight doing? Yeah, that's the question. Well, it's, you know, it's allowing the b3 into king b3. Knight a3, knight b5 with tempo against the pawn. Supposing the knight doesn't get trapped, I don't think it does actually, so knight a3, you don't take, knight b5. So, okay, knight a3 and you castle, suppose, and now I play here immediately. With tempo, suppose bishop pressure makes some sense. Though, actually, then I could, well, yeah, you could take, and but black already doesn't have the bishop pair. Okay, you've defended. If I drop back further, I don't know, this square doesn't seem like anything because the c advance can kick me from it, and then I don't have a follow-up move. Yeah. Well, though, actually, knight b3, king b2, knight c2. Interesting. But in the meantime, it's not doing anything. It's preventing b5, whatever that's worth. No, well, it's preventing b5, and it's let me see, queen. It's yeah, okay. It's giving me ideas of b4, albeit the tactics behind that are still dubious. It's a strange point. Knight a3, b4, knight takes, e.g. pawn takes, bishop takes, king b3. Yeah, but then bishop takes, yeah. Bishop takes, knight, king takes, and my king's on a3, which is not where the king wants to be. Bishop b2 after all of that. It still looks right. It didn't fit with a lot of my analysis, but it looks pristine. I mean, there's maybe the point that if you play through... Well, okay, if I play bishop b2 and then I play knight d2, knight e5, I do whatever, you take, queen takes, king takes, I've completed my development and my king is in an advanced position. So I just don't care about this queen trade. I don't think you would be motivated to take it, which is an assertion. Okay. But then, so why would I play knight d2 though? It's another piece that could use this advance. Yeah, but we haven't broken the pin on the knight. Is a point. Yeah, I guess I wonder when are we gonna make that advance. I mean, we could still play. We could play bishop b2, a4. And then knight a3 with rook support. Not obvious why we're looking for rook support here. Yeah, because if knight takes anyway... Well, I mean, we might take with the bishop, but if we take with the rook... Yeah... Well, we could play rook b3, but... Yeah, it's not obvious what benefit we get with the rook being dragged to a3, whether it's worth a piece coming off the board, though it is bishop trading off for knight, whatever that's worth. Actually, so there's knight a3, rook b1, and then b4 with rook support. And then the idea is that we trade off king support and we justify moving the rook here by placing the rook on b2 to claim the file. And that would rely on knight a3, rook b1. If you play this advance, well, you can't tickle my knight away. I could advance my knight into b5. You'd have to spend a tempo moving your knight. Yeah, this would also come with tempo. So, and then I don't know, I could advance a4 and then drop the knight back behind the pawn or something. My dark squared bishop probably wants to be on e1 already. Bishop d2, rook c1. Well, king b2 with rook c1 as an option. And we again say that this trade is fine. Notably, my king is defending the knight up to the point where I play king b2, and then there's no longer a pin. And so if you play knight e5, well, if you play knight e5 and my king still defends, then we have knight takes e5, queen takes e5, queen takes e5, king takes, I say e5 rather, knight takes d3, queen takes d3, queen takes d3, king takes d3. Even if I've played bishop d2. Okay, though, actually, so we could play rook d1 preemptively. Well, and the point is that we, no, we'd want to play rook c1. Though that was the supposition recently. Okay, and the idea is that I'm going to play the king through. I can play the king through to b2, or in some world with bishop support, we go for the b4 advance. And then I can drop the bishop back to e1 if I so require, gain access to this diagonal. Which actually, we could also then play the bishop through to g3. Alright, I develop. You castle. Castling. Overrated. Okay, so this has gained access to knight h4, which I don't want to allow. Yeah, it looks like we had to follow up with the bishop coverage. And now queen e6 is already looking to punish my king b3. Interesting. I assume this is required. Yeah, because otherwise, well, I could still do this, actually. I could also claim this, because I've got king b2 available. Though I also don't have to follow up I mean, I could play... Yeah, it'd be a bit awkward to play rook c1 and then not move the king, but I could also play knight d2 and wait. Or, yeah. Okay, so if I claim this, you don't have a check. No, but you do... No, and you don't have capture either. Okay, now what? Queen over and say that knight is pinned to pawn, maybe. Doubt that's a good idea. What do I mean? So knight over with tempo. I take. You take. But I don't have back to g3. I don't have to take. We could follow up with king b2. Followed by, well, just say that black doesn't have anything. A4 followed by knight a3. Yeah, what is that rook recapture though? Arguably king defense, king structure defense, but yeah, that's not so lovely. Well, and then alternatively we could play king b2 and go for this with rook support. If black doesn't spend a tempo responding, rook through a4 is difficult for black to dislodge, maybe. Because rook on a4, you could advance against it, at which point I could take en passant, and then I suppose you capture in this direction. Okay, now you're threatening the advance, which I don't like. Alternatively, well, this square is really weak. It seems like we should be able to deny this option. It's denied if we have a4 in. A4. With the idea that if we advance again, right, well, we're hoping that we can gain control over this square. But where is that control going to come from? Maybe knight b2. And so the idea is that if we advance, and then advance, well, actually, if you run past this, maybe we just ignore. Actually, now that I'm thinking about it, I'm not so happy that this bishop got dragged away from defending. Yeah, I'm not so happy that we gave up this, but, well, we're gonna have rook Rook defensive this pawn. Anyway, what idea was I saying? We advance again, and if you advance here, we take. Okay. Which is maybe the surer route. Alright, now... Oh, and you've probably taken the other direction, rather. Alright, so now the idea is that we advance the rook. Well, we first find some way of denying this advance. Do we have such a way? Knight out of the way with tempo. Or knight back to b2, but why would we play knight back to b2? What would be the follow-up? It's orbiting the king. That's why I play it back to b2. It's also denying b2 to the king. Well, then we would be playing knight b2 and knight d2. Well, and then, yeah, if nothing else, we could drop back to king b1. Yeah, not having support for this diagonal with the bishop. In retrospect, we should have just moved the bishop twice in a row to get it to f2 rather than spending the tempo moving the rook to c1, maybe. Would be a point of consideration. The continuing lack of justification for knight d2. And yeah, at this point, knight a3 and plausibly bishop takes. So this knight has been rendered inert, maybe. If I advance, knight d2 to support the e advance, with queen support as well. Takes, pawn takes, with tempo against knight. Well, actually, first we would need to consider probably take advance with rook support. Rook, two knights. Could get the bishop supporting it as well. I'm suspicious. Well, I mean, the first question actually would be, do I have to care? Could I just take? Actually, no, because that pawn is pinned to my queen. Huh. Interesting point. I finally advance against this, and then with tempo against the knight, nothing of mine is under pressure. Okay, tempo against the knight, and if you play it back here, you block your own bishop, you block your rook, and you drop the point of pressure against d4. Though I also now don't have pawn support. How do I insist that my move was not wrong? Huh. Yeah, we could be a tempo to the good. We could, yeah, if we had rook on b1, that would be interesting, though we didn't have that. Yeah. Advance into this with knight and rook support. Much more awkward to go for this advance, I think. Is it, though? Actually, how awkward is that? We now have the knight drop back to cover this pawn, incidentally. And then to try to take advantage of the opened up squares on the queen's, on the king's side, rather. What about this advance with support? Do you counter advance? I'm a little bit suspicious of that idea. Yeah, no, I don't think we have enough support for that. What do we get out of it? Well, I mean, if they had to take, that would be a different question, but the counter advance is more persuasive, I think. Well, then counter advance with tempo. Interestingly. And then plausibly, yeah. For that matter, this is now opened up. Mm-hmm. Takes, knight takes with tempo against queen. Pins. Well, you say pins, I wonder. Capturing notably not mandatory. Indeed. Take. Your knight's just out of position. There's nothing you can do with g2. Instead, advance. Oh, we take the piece, yeah. I'm gonna play it now. Okay. Yeah, and f3 isn't available. Yeah, this effectively forces a trade. I don't know, we could back up with h3, actually. Which is arguably good, but then the knight controls. So one way or the other, I'm looking for a trade. Yeah. I'm done on bishop g3. Drop bishop back to e1, maybe. My opponent won by playing king g7. My opponent defeated me. Advance, because if takes, advance again with tempo against the knight. And then knight here. Knight defends the pawn. Yeah. Then I have knight in, interestingly. And you don't have a light squared diagonal pressure. But yeah, that kind of wrecks that idea, doesn't it? Because if I play knight in, takes, I've discommunicated. And then there's no follow-up pressure against the queen. Takes what? Knight takes. Opens up my rook against your king. I wonder if you should maybe be a little bit more worried about that. Like, you don't have knight captures, for instance, so it takes rook takes. I also have the advance. Advance, your queen is blocked. I can take, but I don't have the minor piece with which to take it. No, that would open up knight f4 though. With the queen, that's true, I didn't analyze with the queen. Actually, this is with tempo. Knight covers. Technically. Yeah. And I don't think that queen pressure is fast. I also don't have this. Maybe it gets off the back rank and looks to recruit this rook. Now my king position is a little bit iffy, but how iffy? Off the back rank. Actually, we could also take advantage of this immediately. Counter advance. Yeah, counter advance. Okay. Looking to play rook f3, but then we don't have a follow-up block for the heavy pieces. So rook f1 is a candidate. It's just, it becomes impossible to avoid trades. Actually, if we play rook g3, queen advance, advance, counter advance. That's also a tempo against my pawn. Rook h1, what is the point? That you can't kick my rook because then I can take the pawn. So you can't get your knight back into the game. Yeah, same story here. I'd have to accept trades. Something's gone wrong. Yeah. It's not anything useful. And now I can't get out of the pin. Yeah, but there's a good reason I couldn't do that, which is that this knight couldn't go anywhere. Like, if I broke the pin, I couldn't do anything with it. Yeah, I doubt it. I mean, even the counter... Well, actually, you don't have the counter advance, but takes with queen support. Not useful here. No, wait a minute, hold on. If advance takes... I recapture with queen support as well, and then I actually have the rook over. Alright, it's not quite the structure we were looking for, maybe, but... no, that reveals... Well, actually, it also reveals my rook, though. Okay, so... I mean, we could also take here instead. So he takes, which blocks the vision of the queen. There's this winning pressure at the end, which might matter. Okay, so let's see. Takes, which blocks the vision of the queen. Knight takes, rook takes, king takes. Yeah, is that actually going to work, though? Let me see here. Takes, rook takes, rook takes. No, it had to be queen takes. We needed to move our other rook in, I'm guessing. We got impatient. Takes advance, drops back, takes. No, it'd be takes here, I guess. I take back. Alright. And where do I take back? Okay. Knight a3, bishop takes, king takes. I drop back to b2, I have no fear. Whether I'm willing to offer the trade. Advance. Advance the king. Huh. Because of knight c5, which also opens up the queen onto the position. Huh. And the idea is that advance, and if a5 takes, I have king defense. No, probably not. Yeah, this is... we'd have to get the queen involved. We could play this knight move immediately. This also comes with tempo. We're threatening to pick up the exchange. Actually, this is a fork. We pick up material. Pins the king, we advance b4. So it's not actually a fork, we don't actually win material. But now this is with tempo against b2 as well. There's also the point, bishop is defending pawn if captures, so... plausibly this is playable. Alright, oh, because of this, because of the fork. And I'd have to have played b4 already. So b4 with eyes on this knight maneuver. I guess I want to say it's not clear where my rooks want to go. Hmm. Hmm. B2, or rather G2 hanging at the end. Yeah, this is unwise. Uninteresting, anyway. what time is it? Oh no. Huh. Well, we gotta blitz it out. Alright, I'm gonna head out. I gotta eat something. I got sucked in. I had no idea what time it was. Alright.